Welcome to Insect Builder channel, large language model automators, Python experts, and my dear friends. Writing DSPy metrics and debugging program, the DSPy program that's I'm talking about. The part 2, looking at bootstrapping process in DSPy. So what to expect in this discussion? So this is actually part 2 of the discussion where we are having about the Phoenix server that helps in tracing the various LLM calls that is being done by the DSPy module. Also, we spoke about the open telemetry as well as the open inference concepts in the earlier video. So try to look at that video in my channel, and this particular video is also part of that playlist. Now, coming back to the discussion, why and the how of the metrics. So metrics, we are going to have a reprimer. I have a video that dives into the metrics and how to use it in this channel, in this particular playlist. So take a look at that. And the parts of the metrics and evaluation, the optimizer compilation, tracing of LLM calls, and spans review. So all these things we will be diving in one by one. So let's go in. So metrics, a reprimer. So what's a metric? If you guys are new to DSPy, then a metric is basically a function that tells how good your program or your module that you have created is, and it helps the optimizer to select the samples or select the data point for updating your program or your module. So that is a very high level discussion about metrics, right? And there are 3 different types of metric. That is simple metric with AI feedback and advanced metric that uses other DSPy programs. So that's are the 3 types of metric, but at the end of the day, all these metric have only one particular objective, that is to check how well your the output, that predicted output by the program is compared with the actual or the gold output or the gold data. So what are the parts of the metrics? So the parts of the metrics start with the gold examples, that is the actual examples from your train and the test data, and we have the predicted outputs that is coming from the DSPy program after it is getting executed. And then comes the important part, the traces. Traces actually contains the input examples and the corresponding predicted objects. That is to be bootstrapped for improving the program. This part is very important. The traces actually contains the bootstrapped examples and only that. It does not contain all the traces or all the examples that is going into the metric. It does not show it. So the metric can return a float or a bool, that is a boolean. Also it can return integers also, but sake of sanity, DSPy does suggest to keep the return value between 0 and 1. As I told you, there is no trace during the evaluation or optimization. The trace is generated if the metric is used for bootstrap demonstration. This was taken from one of the issues, GitHub issues, that was being discussed by the DSPy devs, especially Mr. Omar Khattab, and that's when I wanted to really dive in and understand what's going on behind the traces. So let's look into the metric parts when we are doing optimization. So here is a very simple metric. I'm going to zoom in a bit so that you guys can see it better. So you see, this is the metric function that we have created, and it is going to take the example and the prediction along with the trace. And you can see here the trace is not none. It's actually an empty list. So how is this going to help? Actually, when this particular metric is going to send into the optimizer. So like as you can see here, I am having the example of the optimizer also. You can see that I am sending this particular program, and this particular program already contains the metric in the backend. And when this particular optimizer is used in the compilation process, then you see the trace is getting printed. You can see the trace getting printed out here. It is actually printed as a list because I declared trace as a list at this area. So what happens is when the optimizer process is going on, the compilation process is going on, the example especially that is used for bootstrapping process is getting passed through here as trace. Now you can, then I decided, okay, let us create a very simple metric. So here it's validate, trace and answer, and it's just doing an exact match. So it's trying to get the answer and matching with the exact example answer, gold example answer. But here what I'm doing is I'm trying to check whether the trace, this particular trace is having length that is greater than 0. That means if it is greater than 0, that means it is having a trace data. If not, then it does not. So there is no trace, right? So this is what I'm doing, and you can see that here that is if the trace is greater than 0, obviously you will get to this particular print traces, and the trace is getting printed. You can see the same thing here. And let us go back, let us go to the next slide, and this is the evaluation process. So here this is the optimization process where the bootstrapping happens, and this is the evaluation process of the data set with the metric. And here again there is trace that is actually declared as an empty list, and here you can see the same code is same definition is maintained, but you can actually see there is no trace given out. That is one of the main things that you guys have to be aware of. Why this is required? There are a couple of reasons. First thing is, like, if you're going to try and understand what's the DSPy program doing in reality, or if you want to debug the DSPy program, then you might want some way to trace the calls, right? But this trace, you cannot use it. So that's completely out of question, because the DSPy traces are not present all the time. So you cannot use the trace as such. So the trace has been used for some other debugging processes, but not for the kind of debugging processes that we developers who are using the DSPy module would want to. Right. So what happens now? So that's where Phoenix server comes into picture. So in the last discussion, I had been discussing about how you can use Phoenix server to look at the spans, how to look at the calls that it makes to the API endpoints, that is API endpoints. Here we are going to dive a little bit deeper. So what I'm doing is I can zoom in a bit here, and you can see that I have a very simple DSPy module. So this is actually a COT combined module, and this is taking a chain of thought program, and it is trying to send the news bodies into the program. So here you see I have made a mistake. So in here I am taking the input, the parameter for this forward method is news underscore body, but due to a typo and due to copy pasting a couple of code, I had made a mistake where I say news underscore body is equal to news. So this particular wrong assignment, initially I was not able to find out, and after that the correct one I had updated it to news body after debugging it. So what happened when I debugged? So this is the Phoenix output. This is one of the traces that I got through the Phoenix server. So this is the part of the Phoenix server, and you can see that when this particular program is getting initiated, the news body is Tillerson seeks to reassure worried Europe over Trump. This is the news body. But then when it actually goes through, you can see the news body becomes Turkish hunger striker released for remainder of trial. So this particular news body is completely different from what this news body is going on. So once I looked at the trace, so this trace I was able to get through Phoenix server only, not through the trace that DSPy has. So I was able to extract this particular information, and I saw that somewhere the wrong news body is going through, and when the wrong data is actually going through the DSPy program, your compilation and the optimization, everything goes bad, right? So after this I realized, okay, the mistake is here. Instead of news body, instead of news, it should be news body, and I updated it. Yeah, I could have actually found it out without this trace also, but the idea here is that it took some time for me to even realize that the same data is going again and again. So I had to dive into the guts of the program, DSPy program, and understand what's going on. So this is one of the important steps that you can do for debugging using the Phoenix server. And next interesting thing is looking at the Bootstrap calls. So when you are actually doing DSPy programming and looking at the compilation, it's we always get confused what exactly happens in the DSPy after it gets compiled, after the program gets compiled. So here you can see that the news body has to produce a field called answer, and you can see here that the format of the prompt that is getting pushed by the program in the beginning before the compilation is pretty straightforward. It has a very small prompt, and there is only a single example here. But after the bootstrapping process, so you can see there is no bootstrapped examples in this, but with the bootstrapped examples you can see there are a couple of more examples that has been updated into the prompt. So this idea to look at the trace which is actually entering into the API and going through the request process can be possible using Phoenix. So this is a very small example, and I wanted you guys to understand the benefits and how to use Phoenix server, because observability and understanding what the system is doing by looking it from the outside is one of the important objectives of Phoenix server, and it is doing a wonderful job. Believe me, like using this, finding out what the examples are getting used in the program, or whether to debug your metric as well as your DSPy program. Even in fact, I will be creating one more video where I explain how the F1 score is calculated for this particular metric. I will be explaining it, and we'll be doing some more Phoenix related traces there also. So the key point is that DSPy traces are not present all the time. So you have to have a separate tracing program like Phoenix. So that's where Phoenix helps, and I believe that this video is helpful. Do leave a like and share it with others, and most importantly, subscribe to my channel so that you can get more information about these kinds of knowledge about LLMs and automating it. With that said, practice, 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 practice. See you guys. Have a great time.